Hello everyone and welcome back to science class. Today we are going to be looking at one of the models that we're going to be using in this class to represent atoms. This model is called the Rutherford Bohr model. Now, before we start getting into the actual nitty-gritty details of the model, let's take a look and review atoms. So, everything is made up of atoms. And we know that atoms are made of three different particles: the protons, the neutrons, and the electrons. Now, protons have a positive charge, neutrons don't have a charge, they're neutral, and electrons have a negative charge. If you take a look at this diagram here, this is an example of the model that we're going to be looking at today. So I'm going to show you what we need to know in order to build this model and how we can identify false models versus the real models. So if you take a look at here, we have our protons and our neutrons in the middle. That's our nucleus. And then you'll see that we have these rings around. Now, on these rings, we draw these little blue dots that represent our electrons. Each ring has a specific number of electrons that it can fit. So that's something that we have to consider. We also have to consider the number of rings that each atom has. And to do that, we are going to need to use the periodic table of elements. So if we recall, the periods correspond to the number of electron rings. So for example, we have an atom that is in period 4. That means that it's going to have 4 electron rings. Now, if we take a look at our periodic table, you can see that the periods are represented by the rows. So something in period 4, which is the purplish pinkish line, would be any one of those ones on that line. We count our periods from the top down. So the top one is period 1, then we go down to period 2, period 3, and so on and so on. In total, there are 7 periods on the periodic table. We're not going to be worrying too much about drawing these atoms here. We're mostly concerned about drawing the ones at the top. So let's take a look at how we construct these models. So the first thing that we're going to want to do is we need to choose an atom to draw. So I'm going to go ahead and I'm going to choose silicone. Let's do silicone. So I am going to find silicone on my periodic table. Silicone is element 14. I'm going to take my element symbol, which is Si, and I'm going to write the atomic number underneath it. The atomic number being the number in the box. So 14. 14 represents the number of protons that I have in my atom. It also represents the number of electrons. So I'm going to have to draw in my electrons now. But before I do that, I need to draw in my electron rings. So how many rings does silicone have? Well, if we look here, we have period 1 is the pink one, period 2 is the blue, and period 3 is the yellow. It is in period 3, so we're going to draw 3 electron rings. Now it's time to draw in my electrons. Oh, but wait, there are rules. There are rules to apply. Each ring can only hold so many electrons. So how many electrons can be held on the first ring? Well, the answer to that is just 2. The reason for that is when you look at your first period, you'll notice that in the pink one, there's only 2 elements in that period. Each element represents an electron. So the first ring can only hold 2 electrons. So there we go. I have drawn in my 2 electrons. Now I have to move on to the second ring. And if we look at my second period, we can see that there are 1, 2, 3, 4, 5, 6, 7, 8 elements on that row in that period. So we are allowed to put 8 electrons on the second ring. I often draw them in pairs because it's easier to count that way. Now let's take a look at our third ring. So if we look at our third period, we will see that there are once again 8 elements in that period. However, our element that we're looking at is halfway through. So while there is space on the third ring for 8 electrons, we need to make sure that all of the electrons add up to 14, the number in the middle. So right now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means that we have 4 left to draw. So the outside ring is only going to have 4 electrons, even though there's space for 8. And there you have it. Here is the Rutherford Bohr model of silicon. Let's take a look at another example. Now, let's take a look at the element called calcium. Calcium is located in period 4. It is number 20 on the periodic table. So if I wanted to draw the Rutherford Bohr model of calcium, I know that I need to start off with the symbol Ca and the number, which is 20. Since this is in period 4, I'm going to immediately draw 4 rings. We also know the first ring can hold a maximum of 2 electrons. The second ring can hold a maximum of 8 electrons. The third ring can also hold a maximum of 8 electrons. Now, what about the fourth ring? Well, that's where things get a little bit complicated. See, we start having this part in here. So this is where it gets a little bit more advanced. But we don't need to worry about anything past here. We just need to worry about calcium. So if we look, we need to add up all of our electrons so that they end up at 20. How many do we have drawn right now? We have 2, 4, 6, 8, 10, 12, 14, 16, 18. We need to have 20, so that means we need to draw 2 more electrons. So the outside ring for calcium is going to have 2. And there you have it. There's your Rutherford Bohr model for calcium. Hope you enjoyed this. I will see you next time when we talk about Lewis structures.